everyone, thanks for joining in for the session today. I had a hard time getting started with using Streams API in Java. Probably one of the reasons was that I was already working with Java before it was introduced. And it was kind of difficult to understand the new kind of thinking that was introduced with it. So, in this session, I'll distill that for you. And today I'll talk about getting started with the Java Streams API, why you need them, because it's very important to understand whether you need them, and if yes, why, what you can do with them, and how you can use them in your applications. Quick introduction. I work as a developer advocate with JetBrains, creators of developer tools like IntelliJ IDEA. I have also written a couple of books with my publication on Java certification because I strongly believe that they can help you level up your skills to a great extent. I also work closely with developer communities like Women Who Code Delhi and Delhi Java User Group. I co-lead these groups. I also speak at a lot of places. So, coming back to the topic of the session, Streams API. And before we get into that, I would like you to answer a simple question. How would you request for a glass of water? I can think about two ways. Let's say I could share that I want a glass of water by a simple statement like, please get me a glass of water. Or I could define how I want it in using quite a lot of details like, please walk towards the door, open if it's closed, and other steps as you can see on the screen. So, what is different in both these answers, and how does it impact how you request that glass of water and how you proceed from there? So, the first statement or the request is a declarative style of programming where you're only concerned with what you want rather than how you want it. A very good example would be the SQL statements that you might have written, like select star from EMP. You let your database get the values to you without getting into the details of how the database does it. The second approach is an imperative style of programming, where you are not only concerned about the output that you get, but also about the steps or the process that is followed to get that output. Is either of these approaches right or wrong? No, not really. That really depends on what you're trying to do. Because this was one of the questions that really bugged me for quite a long time. Because when I started reading about functional programming or the Streams API in Java, I kind of reduced that imperative programming is ugly. No, it is not. That really depends on what you are doing. For example, if so now we're taking a step back and we're trying to understand where you should be using each of these styles. For the first one, where I'm talking about the declarative style, if I can trust the other person to get me a glass of water that I can drink, yes, I would like to delegate the work to the person. So that's where the declarative style comes in. It decouples me from going into the implementation details. So if the person tries to kind of rework the implementation details, excellent, good for the person. For me, the process could be improved without me being affected. So that's one of the beauty of the functional programming style or the declarative style. But imperative style, probably I don't trust the other person to get me a glass of water, which I think I could drink. Or perhaps I'm the person who's getting that glass of water. So I need to know the exact details, and I cannot probably delegate further. Before we talk about what streams are, let's talk about. Okay, I think there is a reverb in the return sound. Um, let me use my earphones and dust it. Please let me know if that makes a difference because I hope that should. Okay, so uh, do you think that the sound is better now? Because probably the echo. Okay, so I'll let you take some time and let me know if there is any reverb in the sound. Okay, now coming back to what streams are not. It's important to understand both the aspects, what streams are and what they're not. They are not a place for you to store your data. That's what collections are used for. Collections, files, databases, your cloud, everything else can store your data, but not the streams. Then why would you need them? So they help you to process your data. Let's talk about a quick example. So this could be one of the collection objects that you might use to store, let's say, your colored walls. It could be set, list, map, array. You could also have other data sources like a file or a database, as I mentioned. Okay. So thank you, Dustin. It's better now. Thank you so much. Thanks for the acknowledgement. Okay. So let's get on to our editor and let's live code some of these um, requirements which you might have in your project every day. Let's say we are talking about having a set of values in your collection object like a list, and then which contains, let's say, balls of different colors. One of the very regular requirement could be filter them and have just a few of the balls in the other list which meet a particular criteria. In this case, it could be a green ball. Sorting or regrouping is another common thing that we do every day. And of course, output the values, not so common, but yes, when we are trying to test it. So that's, I would say, one of the common requirement that we have. So let me hop on to my IDE and let's see. Okay, so I'm using IntelliJ IDEA for the demonstrations. So let me create a new class in the package ball. I say insert and let me create a class, let's say ball. And in this class, I want to, because I want something to represent the color of the ball, I would say ball color. And okay, so this is the field that I want to use because this is doesn't exist. Let me quickly create that one. Okay, and let me have just a couple of colors because we don't want to kind of spend the whole session creating colors. So we have green, we have blue, and let's say we have red. That's it. I think that should be good enough. Now let's go back and I say it. The ball has a radius and the ball has weight. I think we are good with creating just um, three fields for this class. Let me move forward and insert some constructors. And let's say I want to insert getters and setters. And I also want to insert the equals. And I want to insert the hash code method. Or no, hash code is already done. Now I'm inserting the toString method. Okay, so let me just add spaces out here because I want the values when they are printed, they should be nice spaced. Okay, and if you have any questions regarding the shortcuts or the features that I'm using, you would see a black rectangle flash towards the bottom of my screen that would display either the shortcut or the feature that I would be using in the IDE. I would not be talking a lot about the features of the IDE, but if you have any questions regarding them, you can post them in the chat and then I would be good to answer them as well. Okay, so now we have our class ball, and let me go back and see what are we supposed to do. So first of all, we are supposed to create a list of all the green balls. Okay, so let me say create another class. I say process collections. Okay, and in this class, let me create a main method. I say I have a list of ball, and let me call that balls, and I say list of colored balls. So I already had this code snippet written because I didn't really want to invest a lot of time writing this code because that would be repetitive and not so interesting to watch. Okay, so now what do we want to do? Let me go back to my presentation. So the first one is that I want to create a list of all the green balls. Okay, so create a list of green balls. Okay, and this example, we would be working with the requirements without using the Streams API. So I say list of ball, then I say these are the green balls, then what do I do? Okay, I say this is new array list and I say okay. Then if you don't have the Stream API, how do you get each element from a collection? You use the external iterator. Of course, in Java, you can access the iterator and you can iterate on the collection objects using that. So let's say I say if for every ball in um, okay, so for every ball, what do I want to do? I want to add the ball from this collection to the green balls list only if it's only if the color is green. So I say if b dot get ball color is equal to green, then I want to add it to my list of green balls. Then I say add. Okay, so this is B and this is done. Okay, so we have a list of green balls because this is an external iterator. It would iterate through all the balls that I have in the list green balls, and then it would get me, then it would add the ones which are green in color to the list which is green balls. Okay, so far so good. Let's see what do we have to do now. Sort them on their radius. Perfect. So I cannot sort the balls before I have the complete final list. So let me say sort the balls on their radius. I'm entering the mini task that I am doing now as comments so that it's easier for us to understand what are we working on. Okay, so I say collections dot sort. Then what do I want to sort? I want to sort the green balls and I want a new comparator because of course I cannot sort on I don't have any natural order for a ball because this is unlike a string, it's an instance of a class. So I have to define what is the order on which I would like to sort it. And as you would know, compare would expect a value negative if the first value is smaller, 0 if they are equal, and 1 if the second value is greater. So let me delete this one and I say return O1 dot get radius is less than O2 dot get radius. If this is right, then I want to return ones. Else, I want to check that again. I say O1 dot get radius is equal to O2 dot get radius. And if yes, I want to return 0. Else, I want to return 0, or I want to return 1. So we are done with the sorting. So let's see what's the next step, which is output the values. Okay, so you say output the values. Now, how do we do it? This is simple. I can copy this, and instead of instead of having a condition, I could say just print the values for me. Okay, so let's see if this gets us the value that we wanted. Okay, so I should see green, and 12 and 87 in that order. So let's see how it does. Yes. And right. Okay. So this is not working. Okay, so probably I'm printing. It should be green balls and not the balls. Right. So I was printing the values from the initial list and not the one that we created, which is the green balls. So let's see, do we get the right values now? Yes, we do. So the ball is green and the radius is 12 and 87, which is sorted according to the comparator that we assigned. Okay, so when you have the red backgrounds, let's see what replacements do we have here. Okay, so this is how you can make your code concise. So again, now let me do the same thing without using using the stream API. So how can we do that? So let's say I want to create a new Java class. I say process using streams. Okay. Now I have the main method, and now let me quickly copy this one. I have my list of values, and then I want to copy the tasks as well. Now, this is the sorting part, and output the values. So, now we are going to do all of these 3 tasks as part of the Streams API. So let me get started, and I can say balls dot stream. And if you remember, I mentioned initially that you can get a stream from a collection object. So in this case, balls is the collection object, and the stream method would get you a stream of values from the balls collection object. In this case, this is a list. We could use stream, we can call stream method on multiple other type of collection objects. So we've now what are we going to do? We have to get the green balls, and that means we have to filter the values in the stream. So the next method that I can call is filter, and the filter takes a value of type predicate. We'll come to these interfaces later. So let's say I'm going to write a predicate now. I'm saying if the filter function gets an instance of ball, it should return, or it should retain, if ball dot get color is equal to green. Now I've done the filtering part. Now I say sorted. And of course, I would need a comparator. I would, in this case, I would say comparator dot comparing. And then I would say I want to compare this. Given an instance of ball, I want to compare it on its radius. Again, what is left? We've already sorted the value using this. We have filtered the value using this method. Now what remains is output the values. So it also says create a list. So let me say uh, collect. Okay. And I say I want to collect it to um, green balls. Okay. So now I have a list which is this, which is green balls. And what this list has is from the original stream, which was called on balls, which had all kind of balls. It uses the filter method, it uses the sorted method, and it uses the collect method. And these methods are grouped into categories like your source, your intermediate operations, and your terminal operations. And I'll talk more about it in a bit later. Let's print out the values. Let me say for, I say green balls dot for each, then I could say given a ball, I want it to be printed. Let's see if this works as we want it to. Okay, can you see the Mario running here? I love this plugin that I have on IntelliJ. Reminds me of the times when I used to play Mario when I was small. Okay, so we have the result for this one as well. Now we are talking about output the way we had for the class when we did not use the collection API. So now let me go back. I have a screenshot of both these classes. Let me compare them because then it would be easier. Okay, so let's compare the code snippets. So this is how you can compare. Of course, the code on the left, which did not use the streams API, is a bit longer. It's not so concise if you compare it to the code on the right. So yes, this is much more concise. I deliberately use the name of the parameters like ball, but if you work with uh, any other code which uses APIs, Streams API, you would see single letter parameter like B or E most commonly. I used ball specifically so that it's easier for anyone reading the code to understand that I'm referring to a ball. Of course, we can also replace this with method references, but that's something which I don't want to touch in this session. We'll get to that part. So, in this, when we compare it, so there are two main differences. So, we have an external iterator when we don't use the Streams API, but when we use the Streams API, we have an internal iterator. Of course, the code looks more concise, and the other thing is that I can actually, instead of saying stream, I could say parallel stream. And depending on the values that I have, this is 5 values, not a big deal. But what if we are talking about reading values from a collection which might have, let's say, thousands or million values, then parallel stream would really help. So, of course, it makes your code efficient because it employs the cores that you have. Now, everything looks good about streams. What are the problems? Okay, so we just had a look on the internal iterators with streams. They were not visible, but we know there are internal iterators because the streams let you iterate over their values. You also had quick brush with the lambda parameters, lambda expressions. So given a ball, so let me go back here. So this is a lambda parameter. When I say given a ball, return to me if ball.getBallColor is equal to ball color.green. So that's a lambda expression which I'm passing to this method. And the last one was functional interfaces. So if I go back to my editor and if I click on showing the parameter information, I can see that it says filter method accepts a value of type predicate. Predicate is a functional interface, an interface which defines just exactly one abstract method. And let's see how that helps you to get started with the Streams API. Okay, so this is a question that as I mentioned initially, I struggled for a very long time. And this is how I got more comfortable with it. So first of all, as I mentioned initially, when you are asking, let's go back to the analogy that I used earlier in the session. When I say you are requesting another person to get you a glass of water, that means you trust the other person to get you a glass of water. The second one, you should know whom to request to get the glass of water. So, to delegate the work, you need to know how the process works roughly. In the same way, the Streams API is really powerful. It lets you define code which is concise, which is easy to read, which can make your processing very effective if you are using parallel streams, if you have very powerful cores which can be used by the Streams API. But to do all that, you need to understand how to use the Stream API. And one point to get started is to kind of group the operations that you can have on the streams. A stream, as I said, it doesn't has any data of its own, so it should get some values from any other source like a collection or arrays. We also have specialized streams like in-stream from a file, cloud, anything. The source must have data, and the source for a stream should be exactly one. Then we can talk about the intermediate operations which are available on stream. The Streams API has a group of most commonly used functions that you could think of, like filtering. If you go back to our example, filtering a set of values, a list of values, is a common requirement. So when you are working with streams, it is good to think about the common operations that you would do for your collection classes and then look for a similar name in the Streams API that would really help you understand that the things that you were trying to do earlier without the Streams API, the API has added a method for it. Of course, we need to understand how to use that method, but it also helps to get into that mind zone that what we were doing earlier is probably available as a method, and the method name would be similar to the operation that we were trying to do, like filter, like reordering, like sorting, or summing, getting average. Now, the intermediate operations could be 0 or multiple for any string. So you might have a source and then you might have a terminal operation straight away without any intermediate operation. And the terminal operation, uh, they let you either collect all the values that you have the way we did. We collected all the values after sorting, after filtering in a list. You can collect the values, you can either print them out using for each, and there are a lot of other operations as well. And the terminal operations can be exactly one. So you can have one source, one terminal operation, which are absolute must, but the intermediate operations are optional. So you can have zero or multiple. The other point to notice here is that the intermediate operations. So if I am filtering my stream, the result that I get is of type stream again. And on that, I can call my transform method, which is, let's say, a map. And the result that I get is again a stream. I can call the sort method. Again, it returns me a stream. So I can have a pipeline of the uh, after I call intermediate operations, and that really helps me get the flow. So this is how the instances of class ball appeared, let's say, in our example. So we started with the list balls, which had 5 balls with different colors and sizes. After applying the filter method, we just had 2 values because we were filtering out the balls which were not green. So we had a condition, let me go back to my IDE. So we had a condition where we said if given a ball to this filter method, if the color of the ball is green, let that ball be in the stream, otherwise discard that. So if we go back to the image, so the filter method allowed you to have just the green balls here. The sorted method, because we defined that we want to sort our values in the ascending order of the radius, this is what we get. And of course, when I say collect, which was a terminal operation, I added these 2 instances to the list green balls. So we started with the stream of balls from the list balls and we ended with a filtered and a sorted list, and the values were stored in green balls. So yes, so this was as I mentioned. So grouping really helps, and to get to understand how you would use that really helps. But of course, nothing helps more than the real examples. So let me get started with working with a few of the Lambda expressions which we used in our code, and then I'll move on to the functional interfaces before moving on to some more examples of using the Streams API. Okay, so, right. So let me, I will continue using this code because, okay, so I have a question. Let me see. It's Sumit Bansal. Hi, Mala. I wanted to check if streams just help by writing less code or do they have any additional benefits as well in the context of the ball example that you used? So, Sumit, I mentioned that yes, writing less code is one of the benefits, but again, as I mentioned, because I also modified this. So instead of using stream, I called the method parallel stream because in this case, we are talking about just 5 values. But what happens if the collection object that you're trying to process has thousands of values? In that case, using parallel stream method to get a stream from the collection object would really help because behind the scenes, the API would engage your multi-cores and you don't really have to bother about writing code that uses multiple threading or that takes care of that part. So that could really be effective because we know that now systems they have multi-cores, and Mm, this could really speed up how you are processing your collection objects or data from your files or cloud or anything, because using a lot of values, storing them in collection classes, in memory, and processing, we do that so often every day, every time, in every class. So that really helps. And of course, apart from making you write less code, it's also easier to read, because let's say if you write this code and if you leave, the person who joins the team later, he or she, of course, they would be more, it would be more easier to understand what you have written, because this feels like the way we talk, because I say get a parallel stream, then filter this stream, sort the stream based on the radius of the ball, and then collect it in a list. So the readability also improves. I know for if you are a junior developer, don't take that negatively. Uh, a lot of time, junior developers think that reading code is not so important, but it really makes a lot of difference when you get to read a lot of code as you are working with multiple projects. So concise code using uh, multi-cores without doing a lot of work, just changing the name of one of the methods, and of course it's effective, is read, write, and faster to execute. Okay, so rather than, so we have a question by Raxby 333. I wonder if you have been using some enterprise Java applications earlier and fallen in love with them. Okay. So rather than creating a new collection, can we update the existing collection with the same streams API? No, you cannot do that, because the underlying stream, the underlying collection object on which you are, from which you are creating the streams, that remains unchanged. That's also a, I would say, advantage, because you don't run into any problems with due to that. Okay, so since we don't have any other questions, let me start. So Club Spinach says hello. Hello. I like the names here. They are quite interesting. Okay. And why does the tusted has I don't know, a crown next to it? Okay. I don't know. I'll probably, if I get to spend more time on Twitch, I would know that better. Okay. So where were we? I lost the track. Let me go back to my presentation. Okay, so we were supposed to work with the Lambda expressions. Okay, so if you are new to Streams API and Lambda expressions. So how can I create a synchronized block code within filter intermediate operations? Okay, so what do you mean by synchronized block code? Do you want to synchronize within the filter intermediate operation? I'm sorry, I didn't get your question, Raxby. 333. So if you could probably add any more details, that would be great as well. And by that time, I'll work on the Lambda expressions. Okay, so Dustin said it's from the Twitch Prime or premium service. Okay, that's great, amazing. Thread safety. Um, so wrap, since we are not modifying the underlying collection objects, what are you trying to synchronize on? Because it's good that multiple threads can work on, let's say, this part of the code. Why do I want to? Because I'm not modifying any values, I'm just filtering on the basis of a condition. I'm sorting again on the basis of some criteria, which is sort me give that a sorted list based on the radius, and I'm just adding it to the list. So I don't need that part. Probably I did not understand the question, and let's see, we'll talk about it later. So, so let's talk about the lambda expressions. Okay, so let me take this lambda expression and let me create another method. Let's say okay, so let me move it a little bit. Now I say I have a method in which, okay, the return type is Boolean, and okay, let me make it public method, and I say filter values, and I expect a value, let's say ball B. And what I'm doing in this method is I say return B ball dot get ball color is equal to green. So what I'm doing in this case, I'm simply accepting a value of type ball, and then I'm saying return a Boolean value depending on whether the color is green or not. Now, is this method different from, or let's say the functionality which is offered by this method, any different from what we just saw here? In this, I talk about the method parameter, which is ball. I know this is a ball because we are talking about a list of balls. And I say call ball color method, and if it's green, just return true or false based on that. A lambda expression is an anonymous function. So in this case, when I say anonymous, I am taking off the method name here. Now, what remains is the return type, the method parameter, and what I want to execute when this method is called. If you go back here, you can see we're talking about the method parameter. Again, the return type is inferred from the body of the method. Now, if I take away the return type, we're really not talking about the access modifier also here. So now what is remaining is the method parameter, its type, and the value or the line of code that we want to execute uh, when this method is called. This is exactly what a method parameter is. And instead of the curly braces, I replace that with an arrow. So let me do that. So now I don't say, so if it's a single line code, I don't need the return keyword as well. Now I say given a parameter of type ball, now I remove this as well. This is inferred as well. So this is what we are left with. Is that making sense to you now? Now, what we have in the method, the body here, which is the lambda expression that I pass to a method, is actually an anonymous function, a function that, let's write it down. It's an anonymous method, which is a method without a name. Then I'm talking about dropping the return type, dropping the access modifiers, then We dropped, what else did we drop? Um, we dropped the curly braces. Drop the curly braces. Yes. What else? Dropped the keyword return. So we dropped a lot of things and we dropped the type of the method parameter as well. Method parameter. What else did we drop? I think that's it. But we added one thing. We added this. Now this is how you can think of um, a lambda expression and a regular method by dropping a lot of things and which I just listed, and by adding the arrow, you can, this is how you can think of the relation between a regular method and a lambda expression. And this is not all. If, just in case, so this is a single line parameter, I could also have multiple line parameter. And if that happens, I could say int a is equal to, let's say, 10, and then I would need the return statement, because that has to have a return statement if the lambda expression is of multiple lines. But we usually don't do that, because if you think that your lambda expression would extend beyond a line, then probably a better thing to do that would be to create a method which has those multiple lines and call that method instead of having your all the code passed to a method which would expect a lambda expression. Okay, so um, okay, so let me just kind of undo that part. Okay, and I'm making this as a comment so that we know how we kind of let's say converted um, um, comparing. No, this is not okay. Comparing a regular method with a lambda expression. Okay. Now, um, how does it work with your functional interfaces? So when we talk about the functional interfaces, these are the interfaces which have exactly exactly one abstract method. So earlier they were also called as single abstract. What am I doing? Can you think of any single abstract method interfaces that you might have used in your coding? Anyone? Okay. So let me, so since there are no answers, okay, so there's the runnable interface, which we use to create threads. So this has exactly one method. Let me go to runnable. Let me say runnable, and I can go to the definition and see that this is a public interface and it has only one abstract method here. So what happens? Okay, and how do I use? So let me quickly create. Okay, so you can create a functional interface which has one abstract method. You can have, as we know, moving Java 9, you can also have methods with implementation in interfaces. So it's allowed that you might not just define abstract methods, but uh, yes, consumer. Yes, consumer. So that's from the Java util function package. So we have consumer, we have function, we have supplier, we have a lot of others. And all the methods that you see in the util function package, I think that's the right name. We should have it here. No. Okay, it's okay. And all of them, they have exactly one abstract method, and then you can pass them. You need to define. So we are running out of time. I don't know whether I should be taking up another um, topic right now, or should I be just moving on to showing you further examples. So let me do one thing. Instead of diving into how to use functional interfaces and how to create functional interfaces, and it is interesting to see if, even though the method names, we just talked about anonymous methods, when, how do these filter methods, how does that, where does this part go and execute? That is an interesting part, but probably we don't have a lot of time. We just have um, okay, so we have another question. Is it possible to perform cast with the return type instead of implicit type reference? Comparable, yes, comparable is interface which has just one abstract method. I'm so sorry, Gatsby. I'm not able to understand your question. If you are talking about this, then yes, I could. So this is using var here is syntactic sugar, because if you look at this part here, uh, the type is determined by the compiler, and it doesn't needs to go to the runtime. So the compiler already knows that the type of green balls is list ball. Of course, I could use that as like this. So this works as well. But when you are talking about casting, of course, any cast needs to follow the rules which are applicable for every casting that we do. Okay, so as I mentioned, so I think we would probably figure out another session to work on how to create functional interfaces, how to write your own functional interfaces, and use the functional interfaces which are created, which are available in Java, the core Java API. Now, let me quickly talk about, let's say, some more examples which, and I would try to kind of have them compare with the SQL statements. If you are already aware of any basic SQL statement, that would also help to. Okay, Chitta 24, ma'am, please finish the last explanation of lambda expression. So Chitta, I already completed the explanation that I wanted to do. So I compared a lambda expression with a regular method, because I talked about how you would think of this expression. How would you deduce, or how would you write this expression? And this is how you can think of writing a lambda expression, because when a method expects me to write a lambda expression, it expects me to know what the input parameter is, and given the input parameter, I can I can say that this is the body of the method that should execute, and the result returned. Chita, is that good enough? Or I don't know, if you are looking for anything specific, please let me know in the chat, or you can also reach out to me. My Twitter handle is um, So probably you can email your query to me as well, and then probably we can talk further, because I'm sorry, I'm not able to understand what explanation you want me to give further. Is it about how you would like to create um, let's say a predicate? Let's say I have a ball, then I say predicate 1 is equal to, given a ball, return ball dot get ball color is equal to green. So this is, I just wrote the anonymous method one. So I'm talking about the anonymous method, Chitta. Um, Chitta, I just explained how you can compare an anonymous method with a lambda expression. I created this method when I said the type, the return type is Boolean. I said check value, and then I mentioned that the parameter that I'm passing to the method is ball B. Then I said return B dot get ball color is equal to green. So this is what I did with the method, and then I dropped things like the method name, which is the check value. If you want, I could do that again. So let me just copy paste here. Then, okay. So I'm going to point 1, which is anonymous method, a method without a name. So I dropped the name here. Then I talked about dropping the return type. Okay. So we don't have the access modifier in this case. Now I dropped the curly brace. So this has gone again. Now I dropped the keyword return, and this is gone too. Now I dropped the type of the method parameter. So this one's gone. Then I added an arrow, and this is what was left. So this is how I created a lambda expression from a method, and this is how you can think of working with the lambda expressions when you are thinking of them as methods, the method parameter and the body that you want to execute. So let me also show how. So this is a predicate. So predicate is one of the interfaces which is defined in the Java API, and this has a method boolean test. So the name of the method is test. It expects a parameter of type t. So this is we are talking about generics here. So type has been defined in the definition, and let's see how you can create the lambda expressions that can be assigned to a type of predicate. So this is the first one. Let me duplicate, and now I can add, now let me say this is predicate 2, or I can just kind of, okay, no, let me keep it as predicate 2. Now, so there are some variations when we talk about the lambda expressions. If I have just one method parameter, okay, thank you, Chitta. I'm so glad that you could get what I was talking about. I'm so glad. Thank you so much. So there are multiple variations of the lambda expressions that I just mentioned. So in this case, because I have only one method parameter, I don't need the round brackets. In the second variation, I just added the round bracket. It's not required if you have just one input parameter, but yes, you would need that if you have multiple method parameters. Now, okay, so instead of adding, I deleted that. So now there's another variation in which I can say, okay, no, I think we're done. Are we? No, this is strange. Okay, so this is, I can also add a curly brace here, but when I do, I should add the return. What is happening here? So it says, okay. So if my lambda expression has just one line of code, then it's okay to omit the curly brace. But of course, if it has multiple lines, then you must include the curly brace. And of course, it has to include the keyword return as well. Um, okay, so we are running out of time, and I think I need to stop now, or probably I can take another 5 minutes and talk about a little more things. I don't know. Lucas, is it okay for me to continue for another 5 minutes, or do I have to stop now? Okay, so let me show you some more examples. Let's quickly do that. Okay, so let me just copy. Um, okay, so create a stream. So I would be using probably incomplete concept here. So this one's already done, I guess, where we say balls dot stream. So this is how you can get a stream from a collection objects. You, as I mentioned, there are specific specialized streams, and you can say, okay, I can say int stream dot range. Then I can specify, let's say 1 to 10, and this would give me numbers from 1 to 10, 1 to 9. But if I make it closed range, then I can get numbers from 1 to 10. Now filter streams. Now you can compare. If you are aware about the SQL statements, let me write a quick SQL statement here. Let me say select star from balls where ball dot color is equal to green. And this is how I could compare that to my statement using. So let me code that. So we're talking about balls, then I say stream, and okay, so we've already done that. Yes. Okay. So let me just kind of skip this one because we've already done that. Mapping would be an interesting thing, because if I have the same SQL query here, and then I say select, instead of star, I say select ball dot, no, this has to be balls dot, what, radius from balls where balls dot color. Now what we are doing, instead of selecting everything, I am selecting some specific attribute of the data which is stored, let's say, in a database which is named balls, and this is my filtering condition, and this is my transformation condition, because from a list of balls now I only want a particular type or a particular set or a subset of data. Now, how would that transform? I would say balls dot stream. Then I would again have a filter where I would say given a ball, get me ball dot get color is equal to green. But now I am saying I want to map it. So I say given an instance of ball, what I want to extract is b dot, let's say, get radius, or I could say b dot get weight. It could be anything. That really depends on what I want to extract. And then I could, let's say, for each, and then I could print it out. I could say system.out.println. So this is a method reference, not a lambda expression. And I could also kind of replace this with a method reference here. I think there are a lot of topics that we have for the functional programming, and we can probably need to talk about it in some other session. So I see that people are moving away because, of course, we're 9 minutes, no, 6 minutes more. So thank you so much. Thanks everyone for attending this session. I hope, I know because in 1 hour we could not do a lot of examples which could help you kind of become a pro in using the Streams API. But I hope it would take away any initial blocks that you might have with getting started with the Streams API. Thanks everyone. Thanks for attending, and good luck everyone. Bye bye.